Hello, everyone, and welcome to our webinar today. I am not Josiah from Edelrid, as you can tell. I'm Kale from Tree Stuff. I'm just going to talk a little bit here while more people are coming in and we get everybody ready so that we're not missing anything. Josiah's got a great quiz at the end of this that you can take to earn 2 CEUs. I would pay attention because he's asking some tough questions. And it has some really good information that you're going to want to remember. First of all, I want to say that we have a couple things going on pretty soon. We have the Arizona Tree Stuff Party on May 6th. So if you are in Arizona or you're willing to drive a while, then go ahead and check out our Facebook events page. You can get all the information there. It's a free event. It's going to be a lot of fun. So I believe that Selena McGregor is hosting that. And, come on out and meet some people, climb some trees, and everyone is invited. On May 18th, we have a scannable webinar with Rob Sterling. He's going to talk about some new technology that you can use to stay safe up in the trees, keep your equipment inspected, and make sure that your PPE is always safe and working. You can find information about that on treestuff.com/webinar, on our Facebook events page, or treestuff.com/events. After that, we have a large Ohio Tree Stuff party that's going on May 27th through 28th. It's like a whole thing. There's camping. It's going to be it's a blast. It's going to be huge. Go to the Facebook event page to find out more about that, or treestuff.com/parties. There's also a Colorado party July 1st. There's a Kentucky party July 22nd. And then in August, we have something that you're going to want to look into right now. It's a thing called Treetopia 2023. That is our second version of Treetopia out in California. It is now 3 days instead of 2 days, and there's a whole bunch of tree stuff style games. There's a whole lot of speakers there. We're going to be doing some great classes throughout the whole time. You can go out and get like 20 some and more CEUs just from taking these classes, as well as some vendors that you can go out and talk to and hang out and party with. So it's a great time. We had probably about 1,000 people there last time. We pretty much take over the whole island of Mare Island in Vallejo. So come on out to that if you're in the California area. And if you're not, it is well worth it. Right now, if you go to treetopiausa.com, there are early bird pricing on the tickets. There's also, I think there's about 40 spots left for camping out there. We have a cool campsite. It's going to be a lot of fun. Going to be a great place to be. We only have 50 spots available for that. So get to treetopiausa.com. It's not treetopia.com. Somebody stole that out from under us, but we're working on that. treetopiausa.com to check that out. So now that that's out of the way, I'm going to move on to what we're here for, which is Josiah. I will post, good point, Josiah, I will post a link to all of this stuff in the chats, as well as the YouTube chat over here on Josiah's page. But Josiah is from Edelrid. He's also known as Strider Trees, or Tree Strider, and he has a great webinar that is about polling stuff, mechanical advantage. And without any further ado, I'm just going to switch over and let him tell you about everything.
Awesome. Thanks for that intro, Kale. That Treetopia event was a good one last year. I'm excited to do it again. I'll be out there again I guess it's in the fall, right? Middle August. Yep. Cool. Well, like you said, I'm going to dive right in here. I've got a lot, and I would love to cover all of it, but I'm also perfectly happy to only get through half of it if it means answering a lot of great questions. So Throw your questions in the chat, wherever you are streaming from. Kale is going to be monitoring that feed. And as good questions come up, he will shoot those out to me. And we'll have a few different times throughout this talk to be able to kind of break for some of those. And I love being able to do that, because then I know at least there's someone whose specific question I was able to address. And that's always, usually if there's one person, then there's several. So like you said, I'm going to be talking about mechanical advantage. Mechanical advantage is kind of a big topic. There's a lot to it, but it breaks down into a very simple idea of how do we multiply the ability of one person or two people or your team, multiply their ability to exert effort in such a way that we can move heavy things or keep heavy things from moving. There's a lot of different applications, so I'm going to cover quite a few different styles of mechanical advantage. It's not a one-size-fits-all thing. You can't have one tool and expect it to be really good in every situation. This is one of those times where if you have a variety of different methods and you have a very complete sort of overall understanding of the concepts, then you can save a lot of time and energy, and you can do very extreme pulls. You can apply a lot of force in a safe way, and that's always the challenge with what we're doing. Is like I will say in virtually every talk I do, tree work is a process of reducing a big complicated problem into very simple, straightforward steps. It's about minimizing variables, and a lot of times being able to pull really hard can simplify a complicated problem, make it a lot easier. The classic example is a spar that's relatively balanced but leaning over a house. If you've got a house here and you've got a big old tree and it's leaning straight over, but you've got an anchor directly opposite the lean, if you can generate enough pull and do it the right way, you can lift that entire tree up off the house or drop it in the yard or whatever. And you've simplified what would otherwise be a very difficult, very risky operation to what is essentially one risky operation. And if you do it right, it's really not that risky. It can be very safe. So I'm excited to break this down a little bit. I want to dive in with a very basic kind of overview of a couple of key concepts that I think you kind of have to know to grasp this well. And it's a physics concept called vectors. So I could explain this, but I actually recorded a video already. It's going to be on my channel later, and we're just going to show a clip of it here, but it does a much better job explaining kind of the difference between a force, a vector, and torque. So Kale, if you could start that at 43 seconds, that would be great. Or I can jump it to where it needs to be, but I guess you've got the audio. Okay.
Welcome to Strider Trees. Today we are talking about forces. It's going to be a little bit of a nerdy conversation. Okay, cool. We're going to break down vectors and torque and all this good stuff so that you can better understand how to take advantage of the strength of the tree, so we're not breaking out canopy anchors that our lives depend on. Today, this one's sponsored by Edelrid North America and the Academy Trained. I'm here in the Academy down in Santa Rosa, where they do awesome trainings for individual arborists and big companies alike. We'll check them out here as we get going.
Those of you guys
hopefully you'll
don't
find
know,
this
the
valuable.
Academy is a fantastic training organization.
All right, we're diving right in. How many of you guys know what a vector is? If you don't remember that from high school physics, I can't believe you. I'm just kidding. Okay, nobody knows. A vector is a more precise description of a force, right?
Yeah, my brother and I went over there.
We all have some idea of what a force is.
And just
the problem with force as a unit in and of itself is that it's not really useful, because forces are always applied in a direction, right? I can't just apply a force. I need to push on something. Newton's third law, every action has an equal opposite reaction. I can only push so long as something's pushing back. So every force has a direction, and that is called a vector. A vector is a force in a direction. And in physics, we will describe that generally as with an arrow, right? And the magnitude of the force, so how big the force is, will generally be described by the size or the length of the arrow, right? And then the direction is the point, wherever the arrow is pointing. So we have a magnitude and a direction associated with every vector. And that's important because when we're dealing with working around in a canopy, or we're dealing with climbing around in a tree, my body is a weight, and my weight exerts forces on the limbs, on the tree as I'm moving around. And the hope is that the forces I am exerting are always less than what the tree can tolerate. Now, there's one other concept to consider besides just the vector, and that is torque. Now, torque is a useful measurement, but it refers to forces that are associated with something that has a pivot point. So a torque is a force in a direction, but against something that that is fixed on one side generally. So torque always refers to some sort of rotational movement. For example, we come over here, here's my little makeshift branch, right? If I take my finger, we'll just pretend this is a vector, right? This is a vector of force. If I exert a force down, my finger is a vector of force in the downward direction. I am creating a torque on this limb. And now, as you can see, the more force I exert, the more the limb deflects from its resting position. And so this gives you some idea of how much force, and intuitively we know this, right? Like I pull harder, branch bends farther. But it's actually a very, very precise association, and all of these limbs and all of the wood and all the structure is designed to be able to tolerate a certain level of deflection, certain level of torque, but in some orientations that force is more tolerated, more easily tolerated than others. For example, if I push, instead of pushing straight down here, if I instead push kind of down but also kind of in, so I'm pushing at this angle, I can push much harder and it's going to cause less deflection. Same thing if I push straight on, I'm going to use my thumb because it's a little easier. I'm pushing straight onto that branch and it's not actually deflecting at all, and I'm pushing way harder. So it's a bigger force vector, but because of the direction of the force, this limb is much more able to tolerate that load, and because it's generating no torque, right? So I'm going to talk a lot about torque because torque is what tends to break branches. When you've got a limb, when you've got a spready canopy, it's torque that will cause this thing to break, not so much force in line with the grain of the wood. Wood is super strong.
All right, so that's a little clip from a series that I'm going kind of deep diving into vectors there. The takeaway on that, what I'm hoping you guys get is a torque is a vector in a direction. A torque is a vector around a pivot. So a vector, any force that is ever exerted is always exerted. We describe it as a vector because you can't exert a force without a direction. You can't push on nothing. It's the, Newton's laws of physics demand that any force must have an equal and opposite force, which means it must be acting in a direction. There's just no way, there's no other way to do it. But when you have, like with trees, we almost always deal with forces where we are applying a force to one part of the tree, but there is a point where the tree or the branch or whatever it is we're trying to move could pivot. And so very often our vector of force is actually exerting a torque on something. And that's important because as we deal with some of these systems, as we talk about mechanical advantage has the ability to dramatically increase the amount of force at any given moment. So we're going to kind of revisit this picture and this graph, but I just to show a little example here, if you can see my pointer, here we've got this tree, kind of a generic rigging situation. If there was something down here, what we've got is a tension line through a redirect and then through another redirect. And this is just sort of describing in which order you might remove these branches. What needs to be noted here is that the force of weight, the force of gravity, is always exerting a force in the downward direction. And so we've got this downward force as soon as these limbs are hanging or as we add tension. But the beautiful thing about ropes is that they transfer force along their length in tension. And so pretty much anytime you see a rope, you know that there is a force being exerted along the length of that rope in the direction or along the line that the rope is taking place, which is, complicated, sounds complicated, but it's intuitively simple. Like everyone gets that. So you pull on a rope, you're pulling in line with the rope because that's the only way to exert a force. Now these deflection points, these redirects, as we call them, they are designed to sort of give us a better positioning, maybe prevent the branch from swinging somewhere we don't want, etc. But the problem with a bad redirect is that it can apply a torque on a branch, a very significant torque. So if we look at this little picture here, we've got this redirect in particular. If you can see the angle of the force vector being exerted by this rope in tension on this particular time point is described by this blue arrow. Now, that blue arrow is a very small force because if we look at the angle of deflection here, it's really broad. So if I was to compare it back over here to our graph, maybe we've got a 30-degree deflection or something like that. So at best, this branch might be supporting 52% of the weight of what is on the line, maybe roughly. But if that's a big branch, 52% at a bad torque, that could cause damage, especially if this is an included union, if it's a poor union, if there's rod in there, etc. So perhaps a better positioning for this might have been over here, because then the way this spar leans out that direction, that same arrow, that arrow of force, might be pulling that spar more into itself. It's standing it up rather than pulling it over. It's not trying to separate the union, it's actually compressing the union. So over here, even though it's a smaller branch, might actually be a better position for that. Now, I'm not going to get too carried away with rigging forces and vectors because that's a whole conversation itself. But it's something you guys have to think about when you're setting up for a big pull, because if I'm going to pull this whole tree over, I don't want to, I'm applying an enormous torque, hopefully to somewhere fairly high on the tree so that I've got lots of leverage to stand it up and pull it over, but I want to be careful about where I position that. The other thing to note, and this is something to write down and pay attention, if you ever want to know the exact direction of force through a redirect, you draw a bisecting angle. Now, a bisecting angle is an angle that divides this angle in half. So naturally, a sling will align along the torque vector. So it'll actually point exactly where that force is being applied. And so in this case, that's not quite perfect, but it's pretty close. It's kind of going like this. And this one's actually, that's funny. This one's actually going this way a little bit. So if you draw a bisecting angle between in the center of your deflection, then that tells you the direction of the force vector on that on that deflection point. So we'll talk about this a little more. Sharing the load, it's a useful thing to know. You can kind of spread these forces out in the canopy. So sometimes if, for example, you've got a big tree, big spready canopied tree, and you're trying to pull it over, but there aren't any good leads. I'm thinking of like a big silver maple where you've got a massive trunk and then all these tall shoots. If you were to run a line through the whole canopy, sometimes you can make a whole bunch of really wide open angles so that none of those unions are ever actually seeing all that much force, and you can still pull in the tree really hard. So something to think about, something to consider. Like I mentioned before, when we're dealing with mechanical advantages, we're almost always trying to do something hard, and we're trying to make it easy. We're trying to amplify or magnify a force. Now, force times distance equals work. So the goal of what we're doing is to do work. Anytime you move something, you have done work. So what a lever does is it converts force and distance back and forth. This nice little GIF here, we've got a short lever arm and a long lever arm. The short lever arm is experiencing a higher force, but it's traveling a shorter distance. Out here on the far end of the lever arm, we're experiencing a lesser force, but it's traveling a much longer distance because the arc of the travel of that part of the lever is farther. Now, this exact same concept is true when it comes to pulley systems. When we're dealing with pulley systems, like for this example here, we've got a 4-to-1 system, and this 200 kilogram load is moving 1 meter up for every 4 meters of rope that are pulled. So in light of that, one of the things we have to plan for, and this is something I'll revisit again, one of the things you have to plan for is, okay, if I know I'm going to have to pull really hard, I need to build a system that has enough travel in it in order to complete the whole pull. Now, that can be a problem because if we've thrown a whole bunch of pulleys in series here, then we may not actually have room to squeeze all those pulleys together. We might run out of room before we actually pull the whole thing over. And there's better and worse ways to build systems that are sort of more, call it space optimized. So certain types of systems are maybe faster or use fewer pulleys, but your pulleys end up jamming against your anchor faster, and so you limit how far you can pull. Whereas systems like this, which is kind of a basic, it's a simple system or a reeve system, you have to go through a lot of rope, but your pulleys can be as far apart as you want, so long as you've got 5 times the rope as the distance you're trying to pull. And so sometimes that you may not be quite as efficient with your pulleys, but you might be more efficient with you might be able to get more length because you've got a long rope. So another thing just to consider. But the idea here is mechanical advantage is leverage. And in order to do the work we have, we want to be able to amplify our forces. So again, going back to something I said earlier, tree work is about minimizing variables. And one of the variables that is always present on a tree job is personnel. I like to operate with minimal personnel. When I was running my crew in California, there were usually 2 guys on the ground and then myself. And that was enough to do most jobs because we were able to sort of optimize our flow. We used machines. I had a GRCS when we were rigging. We had a little ditch witch for when things were coming down. One guy could move a big old heavy piece just the same as 2 or 3 would have to. And so it made for very efficient work. By using mechanical advantage systems, by using machines, we take some of the variable of personnel out of the equation. Now, personnel are fantastic. It's great to have extra help, but they're also a liability. If someone gets hurt, injuries are a huge expense. If someone, and that can happen so easily, even if you're being safe. And you don't always know. There's someone on your team may not always know all the things that you know, and it might be hard to explain. So there's going to be some compromises in time and training and all these sorts of things. A lot of complications that get introduced by more people. So sometimes we can make leverage work to our advantage and avoid having extra personnel. We can save ourselves some injury. We can set up systems that maximize our efficiency without adding more variables, without overcomplicating things. All right. When we're setting up mechanical advantage systems, there are a handful of things that are really important to consider. These are a few of the prominent ones. I'm going to run through some questions that you should ask yourself every time you're setting up for a big pull. And this is the case through all different types of pulling as well. So sometimes you're pulling, like I said, I'm going to keep using an example of pulling a tree over because that's one of the classics, but sometimes you're lifting branches, sometimes you're pulling equipment out of a ditch, sometimes you're maybe trying to roll a log or drag some brush up a hill. There's a lot of different scenarios where you might be employing a mechanical advantage system. And anytime you're setting that up, these are all factors that you need to look closely at. So I'm going to go through a few of these, starting with worst case scenario. So using that tree over house example, we need to look at the worst case scenario. Is this thing backed up? Is there any scenario where that tree lets go and falls back and ends up on the house? When I'm going through any process in tree work, one of the things I think of is, okay, let's simplify this until I can tolerate the worst case scenario. So even if everything goes wrong, that is an outcome I can accept. So that means, avoiding circumstances where someone could die, obviously. So if you're pulling a tree over and your guy pulling the rope is within the range of the tree falling, that's a worst case scenario. In that situation, someone ends up dead. That's not an acceptable outcome. You need to change the strategy must change. If you don't have enough rope, well, then you got to buy another rope or figure out a system where you can use what you've got and keep personnel out of that crash zone. The same is true with sometimes when things cut loose early. when you're working around a pivot, when you're trying to stand up a tree, or maybe you're working and you're not pulling it directly against the lean, maybe it's got a little bit of side lean too, and you're concerned about the possibility of the hinge breaking, or even, maybe you're cutting it and maybe just cut the hinge a little bit early and that tree could pivot. Where is it going to end up? Even if that line holds, a tree can fall up to 90 degrees away from the direction where you're trying to pull it. So if that is a possibility, if that's a concern, solution for that. I don't know if everyone just lost me there, if that was something, but anyway, okay, good. Distance from targets, that's another big one. So like I said, if you're pulling over a tree, how close are various things of value? Can you get everything out of the radius of that tree? Like I said, if you're only pulling with one line, it could fall anywhere within the 180-degree circle in the direction of your line. And so that there may be unacceptable outcomes, and we should look at either moving the stuff, moving personnel, or introducing a second or third guideline so that we can be confident that the tree's going to go where we put it. Setting a couple extra lines, while it can be tedious, can also be efficient. Like that can be the fastest way to get the tree done. If instead of climbing it, making a dozen cuts and rigging those out and then setting a line, if instead I can just put a second line through the tree, anchor it off well, add another mechanical advantage system, lock it off, and then I'm good, well, then that can be a great way to solve the problem. Again, it simplifies it. We're reducing variables. We're taking 15 cuts and a climber in the tree and some rigging out of the equation and introducing a rope, which hopefully the condition of your ropes and you're able to judge whether it's going to be sufficient or not. So that kind of covers the where things go if something breaks in a similar, it's a similar thing there. The weakest links is another thing to know. How good are your ropes? How new are they? Rope stretch, energy storage. So anytime you're pulling hard, you are introducing potential energy into these ropes. All of our ropes have some stretch to them. Nylon, polyester, they're all designed to stretch to some degree. Even amp steel, even Dyneema, which we'll talk about a little bit more as well. It has some stretch. And so as you pull harder, you're introducing that potential energy. And if something cuts loose, things could go flying dramatically. I was on a job one time, something broke somewhere and I thought a gun had gone off, and you look around and there's a big old dent in the back of the truck from the rope that had sprung and slapped the back of the truck. And there's things that went wrong in that scenario. It wasn't a bad accident because all the worst case scenarios were acceptable, but it was I was down a rope, the rope broke in half, and that was a bummer. So it's important to know what the weakest links are. Generally, you want your rope to be the weakest link. Sometimes if you're using rope clamps, like these guys, or a hand ascender, they can be a really fast way to add progress capture to a line. So this is just an Edelrid unisender. It's just a cammed ascender with a little bit of teeth in here, moves one way along the rope. It can be a really fast way to attach a 5-to-1 system to add some tension. These are really only good this one in particular is good for up to 4 kilonewtons. That's what they say is the limit. These things will tend to strip the sheath off of rope. All of this style tooth cam, they're really hard on the sheaths. So they will tend to strip the sheath off somewhere between 4 and 7, depending on the device, depending on the rope, a lot of variables there. And just so you know, 4 kilonewtons is one of these guys. These have an MBS of 4 kN. So if you're using this, but you wouldn't pull on it with this, then maybe you got to switch it up. One of the ways you can use these more effectively is putting it towards the input side of your mechanical advantage system. So if I've got a 5-to-1, my first pulley is only seeing twice whatever I'm able to pull, whereas the last pulley or the tie-in point at my load is seeing roughly 5 times what my initial input force is. So if I have my first pulley on this and I'm only pulling 100 pounds or 150 pounds, and so at most it's seeing 300 pounds, man, that might be okay. But I wouldn't use one of these for a system where more than 1 or maybe 2 people at the most are pulling on it at any given time. So these can be the weakest link. It's also nice to have friction hitches, because these you can kind of program to be the weakest link. So a lot of times, again, if you're using one of these to attach a pulley to a rope, it doesn't have to be this one, or you could have bigger, stronger ones, whatever. But if you're using this, a lot of times you can tie a knot in such a way that it'll hold really, really well when you want it to, but at a certain load, it'll start to slip. And there's no way to guess just what that's going to be. You kind of have to guess and check. Certain friction hitches hold better than others. If you tie it tighter with more wraps, you're going to get more bite out of it. But a lot of times, if you do it right, you can make this slip before anything else is going to break. And that can be a good thing to know. One of the things I like to do is mount my pulley with one of these guys, and then I'll use a backup knot below it. So I'm not weakening my primary pull line with a knot, but that knot serves as a stopper. So if this does start to slip and it hits that knot, then it'll stop. So it's kind of a two-layer system where I get to see how close to my limits I'm pushing. Because the reality is, if we're pulling with 5-to-1, 12-to-1 systems, if we're pulling with a rope jack through a 2-to-1, if we're pulling with machinery, a lot of times we're pushing limits. And it's good to know what those limits are, and it's good to be able to experiment and have sort of progressive ways to sort of get data for our own experience about how close to those limits we were. Now, obviously, with a backup knot, well, now I'm not going to get the advantage of slipping anymore, and if it catches, now something else is going to break, and I should know what that's going to be. But it's a good way to be sure and be safe, and to something you can look at later to see just how much load maybe you put on it. If you ever do that, obviously you got to test it first. So one of the things to consider with rope stretch, energy storage, and regarding weakest links as well, is that ropes all have what's called like cycles to failure. So ropes, when you buy a rope, it'll have an MBS, a minimum breaking strength. And that minimum breaking strength is an estimate based on testing, where they take a whole bunch of samples of a rope, break it, and they chart out at what load that rope broke with a straight pull. And there's a lot of different methodologies here. There's no guarantee that your method of pulling will result in the same breaking strength. Ropes have a lot of characteristics. For example, if you pull really hard and fast, you don't get as much peak load. If you pull slow and then stop, and then pull some more and then stop, and then pull some more and stop, a lot of times you get a much higher number. But it's hard to know what those numbers, what testing methodology the company actually used. And so take those MBSs with a grain of salt. Don't count on it always to do that. But it's also worth knowing that MBS is only guaranteed for a brand new rope. Now, because of the idea of cycles to failure, every time I approach that minimum breaking strength, every time I approach the physical limit of the rope, I am decreasing what's called the reserve. So a rope will have, a certain number of cycles where it's going to be reasonably strong, but the more often I approach a higher percentage of its MBS, the less reserve it will have. To make that more clear, say I've got this line here. This line is a woodpecker, 11.7 millimeter. It's good for about 6,000 pounds roughly, right? So if I'm using it to climb and I only ever put at the most 200 pounds on it, maybe 300 if I take a little slip and drop into it dynamically. 300 pounds is half of, 2% of what this rope can hold. It's a pretty small percentage. I could essentially do that. I could cycle it with that thousands of times, probably tens of thousands of times before I'm going to deplete the reserve. But if I then use this rope to rig a branch, and it's a 300-pound branch, but it drops 3 feet, and now all of a sudden this rope is experiencing a 600-pound load, well, that's 10% of the rope's minimum breaking strength. And now this rope may only be able to tolerate that kind of loading maybe a few hundred times, not tens of thousands. So that's kind of what I mean. If I were to then put a 5,000-pound load, well, maybe it would hold, but maybe I could only put a 5,000 load on it 4 times, 3 times. Who knows exactly? If you look at the dynamic testing for rock climbing ropes. They test them they don't actually give an NBS, they give a number of UAA or UIAA certified falls. So they have a testing apparatus where they drop a weighted body onto the rope, and the rope catches that weight, and it has to be able to catch that weight a certain number of times in order to be approved for that function. And then you can see those lines will all say rated for 4 falls or 7 falls. And it's a measurement that tells you a lot more, because yes, something with a higher number of falls might be a stronger rope, or it might just be better energy absorption. It's hard to say, but it gives you the idea that there's a reserve to it, and you don't want to deplete the reserve. So if you're pulling with your really old ropes, don't count on it to max out its strength. Don't count on it to hold if you're approaching the limit of what its original NBS was. That would be really risky business. If you know you've got a critical operation, you've got a job where you know you're gonna have to pull really hard, sometimes I'll buy a new rope just for that. You know, if I'm gonna do a big nasty tree over a house and it's gonna cost the client $3,500 or whatever, you know, if I spend $200 on a new rope, at least I have the peace of mind that I know what my pull limits are going to be. So that can be useful as well. Jump to the next slide here. Both when it comes to real work and in my conversation here in my PowerPoint, I want you guys to think KISS. Keep it simple. Obviously, there are so many different types of systems. I've gone and struck out this complex system. Everything I'm going to describe to you is either going to be a simple or a compound system. These compound systems are much more easy to conceptualize than a complicated mechanical advantage system. It's harder to get a handle on just exactly what the mechanical advantage is, and it's useful to be able to do quick mental math and have an idea of how hard you're pulling, because generally when we're in these situations, we want to pull with the least necessary force. Over pulling is rarely a good idea. This is, you know, I love the phrase overkill is underrated. And while a lot of situations that's true, when it comes to pulling, we really don't want to over pull. A lot of negative circumstances can result from over pulling. There was this awful reel on Instagram the other day going around of this guy who was taking a top and it looked like he had his face cut and he was starting into his back cut. His face cut wasn't exactly in line with the weight, or it was being pulled. It looked like it was being pulled. And the whole thing barber chaired on him before he was halfway through his back cut and came down and clobbered him. And that's a problem. Like, that's not a good solution. So it's useful to know just how hard you're pulling, at least to have some kind of an estimate. And so I say, let's stick with simple and compound systems. Stick with what you know and what you can understand. As you get better at these, you will be able to understand them better, and it'll be more obvious to you just how hard you're pulling. The other thing that you really have to know and pay attention to is when you've got a pulley that is a redirect and a pulley that is actually giving you mechanical advantage. So if you look over here at the fixed and movable, both these pulley scenarios involve one pulley and two legs of line. But in the leftmost scenario, the fixed one, that person is not actually, they don't have any mechanical advantage. All that is serving is as a redirect. He's pulling exactly the same as the weight of the load. Now, if you look over here, we've got two legs of line and a pulley, but the pulley is moving. And in this one, you actually do have mechanical advantage. There's two legs of line, and each leg of line is seeing half the load in this scenario where the pulley is moving. And so he'll actually get some mechanical advantage out of that. Now, compound pulleys, this isn't a very good example of a compound pulley because this guy is pulling, and he's pulling half the load here, half the load here. So he's getting a 2-to-1 mechanical advantage, but he's got two pulleys in there. This one is, again, only a redirect. So you have to know when you're setting up something, you have to be able to calculate and recognize when a pulley is serving as a redirect or when it's actually providing mechanical advantage. So I'm going to go through a little bit later on. I'm going to set up a whole bunch of different pulley systems for you guys. Please leave your questions in the chat about those pulley systems. If there's one you like to see, if there's one, I'm going to show you probably 3 of my favorites and a couple of different variations if we have the time. But that'll be as we get a little bit deeper here. I'm a big fan of compound mechanical advantage systems, and we'll demonstrate some of those because I like to use those big old blue, I guess they're CMI arborist blocks. They're fantastic. They're burly as all heck, and they're really smooth. They have great efficiency, and you got a couple of them, so why not string them together? You can get a lot of mechanical advantage with relatively few number of pulleys using those types of systems. The simple 5-to-1s, generally when you buy a complete system, like a Jag or a Edelrid Ka, those are simple 5-to-1s. They're called sheave block systems. They're all together, and it's a simple system. So I'll demonstrate a couple of those as well. So let's talk about rope. What is a good rope for what? Hopefully you guys are familiar with these kind of basic, these are all the different types of rigging ropes. I'm categorizing these somewhat differently, and I will go through why. But if you have any questions about any specific rope, just let me know. I'm going to go through these because I think these are all useful, and they're ones that hopefully most everyone has seen. So the first one here is the rope that you might have on a Mazda rope puller. It's a 3-strand rope. Generally, these are very stretchy. They have a lot of twists to them, but they're cheap. They're cheap and they're pretty durable, and they hold up well to kind of natural crotch uses. This is not one I would recommend for any sort of heavy pulling. What you'll find is that they tend to twist as you load it. And so if you've got it through a 2-to-1, sometimes it'll twist up the 2-to-1 and add a whole bunch of friction and just completely negate all the advantage you had. I'm not a huge fan of the Mazda rope puller for that. Well, that being one of the reasons. But it's, again, if we're trying to simplify the process, trying to eliminate variables, a rope that has a lot of stretch and twist is adding variables that I don't want to deal with. So here is a little bit of an improvement. Again, this is kind of an older rope. This is Samson Blue Streak, pretty common. There's a few others, like Teufelberger makes High V. It's your 16-strand solid braid. This stuff is, again, pretty burly. It holds up pretty well in natural crotch. A lot of folks have this stuff around. It's been around the industry a long time. But again, this one has quite a bit of stretch. However, it's much more dimensionally stable. It doesn't tend to twist nearly so badly. So this one's not a bad one for light duty rigging if you've got it and you need it. The rope clamps will hold on really well on that stuff. But again, a little bit stretchy. Just so you know, a 1/2-inch 3-strand rope, this one in particular is good for about 5,100 pounds MBS brand new. This Samson Blue Streak is good for 69. That's almost 2,000 pounds stronger. So they're the same diameter, but you get a lot more strength out of this type of rope construction. Jumping up one more, we've got Dynazorb, which is a little more sophisticated line. Now, Dynazorb is it's in the name Dyna. It's dynamic, so it is actually great for negative block rigging. So if you're pushing chunks and you want to catch something, you want to absorb that energy, and you don't want it to shock load your anchor point. So you want something that's a little bit stretchy. Dynazorb is great. It's also fairly inexpensive because it's nylon polyester construction. Super simple stuff. It's strong too because nylon is very strong. That's good for about 10.5. So again, you're a couple thousand pounds, 2,500 pounds stronger than this Blue Streak. Next, we've got here, this one's Dynazorb. The blue one here is Dynazorb. This bottom one here is Pelican. It's Ape by Pelican, which is an all polyester rope. And this is actually my kind of go-to rigging rope under most scenarios. It's not particularly big, but it's very static. So I can get a lot of wraps on the GRCS. It'll fit in there. I can pull a couple thousand pounds. It doesn't stretch, it doesn't twist. It's a very robust rope. It's polyester on polyester. It's not very expensive. It really is a very simple double braid. But I find that works for me as long as I'm running through metal hardware. Now, both of these will glaze and they will burn up really badly if you're running them natural crotch. So you'll go through a lot of expensive rope if you do that. Wouldn't recommend it. Now, Pelican Ape's good for 11,000 pounds, so it's actually even just a little bit stronger than Dynazorb of the same diameter. Now, here I've got a chunk of am steel. So this is 1/2 inch am steel. Anyone want to take a guess at what 1/2 inch am steel weighs, or how much load it can handle? 34,000 pounds. So am steel is Dyneema. It is one of those UHMPE ropes. The qualities vary dramatically, so careful buying the cheap UHMPE from China. Some of that's okay. Some of it is way less strong. Be careful if you're using that for winch line or whatever. This is something that's almost completely replaced cable for winches, for rescue rigs, if guys who are pulling trucks out of ditches. A lot of the really heavy duty lifting lines on giant cranes in the marine industry. This is a great line because it's completely static. It is far more static even than straight polyester. It also has the advantage of that staticness is that it has very little stretch. So if it does get loaded and then break, it doesn't store much energy. So you have less danger to personnel, bystanders, whatever. So that can be a huge advantage if you imagine, like, when you're towing a rig out, you don't want to have your tow line break and then have something metal go flying through the window of the car that it holds onto. This tends to be a lot safer for those sorts of high strength, high towing, high pressure operations. The downside is, particularly in our industry, it's not terribly abrasion resistant. It's really expensive, and it's slippery. It's really slippery. So it's difficult to have progress capture. It's difficult to, you couldn't just wrap a hitch cord around it and expect it to bite. If you're wrapping around a porta wrap, you'll get a bunch of wraps on it, but it might still slip. And it's overkill. It's so much more strength than you really need. This last one here is called Krypton D. It's a relatively new product from Pelican, and it actually has Dyneema in the core, but polyester on the outside. So it has the potential to kind of be the perfect middleman between the super static poly and then your am steel. This Krypton D is good for 19,000 pounds at 1/2 inch, which is kind of just outrageous. That's not quite double Dynasorb at the same diameter, but that's because it's got that Dyneema core. It's going to milk a lot. It's going to be expensive. But this would be a good static lifting line as well, potentially. They make crane slings out of these things. They're usually a little bit thicker because cranes lift very statically. I'm looking forward to getting to play with some of this here in the near future. I'm going to see how it interacts with my GRCS. But those are some different constructions and different material types. But the important takeaways to know is that, hey, when you're lifting, when you're pulling, when you're dealing with a lot of tension, best to use relatively low stretch lines. It makes things simpler, safer, more predictable. If you are doing dynamic pulling, if you are, like I said, dropping chunks, if you are trying to pull something a relatively long way, or you're pulling with your truck and you don't have perfect consistency with your pull, well, then sometimes something a little bit more dynamic can be good as well. But generally, I like to keep things simple. When I'm dealing with pulleys, when I'm pulling by hand, I'll go static as much as possible. When you're pulling, go ahead there. Cool. Well, I'm almost through. Yeah, I think we're doing all right. You got any good questions? I'm gonna have a chance for that here in just a minute. I'm probably not gonna tie any of these knots, but okay. Cool. Well, I'm gonna just keep rolling here. When we're pulling hard, obviously knots jam up hard, and it's good to know some knots that are easy to cut loose. These are all ones I like. The timber hitch is the go-to for a porta wrap. A figure 8 on a bite is great for a termination knot. People will argue that that's hard to untie. If you tie it properly, it's not bad. And what the important thing is that the load strand is not wrapped around the bottom. You want the load strand up above, and that keeps it on those two. But it's something you'll have to look up. It's not easy to describe. Obviously, bowlines are great, but a bowline will take at least 60% of the rope strength out. So this is one of the weaker knots, but it does untie very easily. Bowline on a bite is similar, except you can tie that midline very quickly. That's a good knot for, again, for a midline loop of some kind. Blake's hitch, y'all climb on that. If you're gonna, it's just a friction hitch for a single line, VT. Again, that's what I'll use on my hitch cord if I'm putting a pulley midline a lot of times. You can pull on it really hard and it'll cinch down, but it'll still come loose super easily. Alpine butterfly, and this one is called the Circus Bowline. Of the two, I prefer the Circus Bowline. It's a little bit hard to visually tell when it's tied correctly, but it comes out a lot easier. The Alpine butterfly can really jam up hard if you're pulling hard on it. So these are all great knots to know, and I will be using a few of these here as I demonstrate. Now we're going to dive into a bunch of different use cases and sort of a couple different methods of pulling here in the next section. So if that's what you're looking forward to, then that's coming up. With each of these different use cases, the main points of consideration are, okay, how much control do I have? Because again, we don't want to overpull. Overpulling can get you into trouble, or underpull. Yeah, we got to be able to pull enough. So that's output force. You know, how hard can I pull? You know, can I use this thing to lift something heavy, or am I fairly limited? The distance of pull. So how far can I move it in one go without having to reset or change the system? And setup difficulty. If you've got groundies or if you've got relatively untrained people or new people on your team, how hard is it to set up? How hard is it to train? And cost. Is this expensive? Is it really gear intensive, or does it use a lot of equipment? Those are all different characteristics, and I'm kind of rated a bunch of these on those different categories. Let's see. All right, so here's a few different use cases, and you'll see what I mean by dynamic and static. So if I'm introducing lean, if I've got a tree that's static and I'm trying to pull it over, that's a dynamic pull. I need to continue to pull it the whole way through, at least until it's leaning in the proper direction and falls. And so dynamic pulling methods are kind of harder, and most of these are going to be great for static, but some are going to be better for dynamic. So I'll kind of delineate that a little bit as we run through these. Obviously guying for controlled felling. So if I've got one dynamic pulling line to try and go it the right way, and I might have a second line where I just added tension and then locked it off so that it can't go 90 degrees to the lean, and then it can only go the way I'm pulling it. So that would be, that's a static purpose. Generally, you just need to create some tension, lock it off. Installing cable, like if you're got two leads going out different directions, you want to pull them together a little bit before you install cable. Again, that's static. You pull it and then it sits. You do your work and then you take it down. Tensioning rigging systems, that can be static or dynamic. Sometimes you just tension it, lock it off, and sometimes you need to actually lift it all the way up. I love rigging with a GRCS, being able to tip tie and stand up a branch and then have it pop up all nice and smooth and safe. Dragging material, I've set up highline systems to drag brush up a hill. That can be great, but that's dynamic. You need a really long pull distance. Removing snags, hangers, again, that can be one or the other. Sometimes it's a great way to get it. Instead of climbing up the tree to knock out the hazardous thing, let's just throw a rope and pull on it really hard, see what happens. Sometimes that's a good option. Equipment rescue, that's more of a dynamic situation. Aerial rescue, again, that's more of a dynamic lift. It can be static as well, though. Sometimes you can just lift them, transfer them over, lower them, and then you're out. So it's good to know, it's good to have, like I said, more than one system in your pocket, more than one tool in your toolbox, because different systems will perform very differently in these different circumstances. All right, so jumping into the easy ones here. We'll start off with people power. How many people you got in your crew is how hard you can pull. I did some testing outside just with myself on a load cell, and made some educated guesses about what your average guy is going to be able to pull. I could pull just a little bit harder than this, but this is probably pretty close. So if I was completely braced and I pulsed and pulled as hard as I could in kind of a dynamic way, I got up to about 300 pounds. But if I was holding steady, you know, at most I was getting about 150, 160 for myself. Average guy, 140 pounds. That's not a lot of force, but if you can steady hold, lock it off on the tree, and then vector it, I was able to get a peak load of 700 pounds just by myself. So I will demonstrate what a vectored line is. In fact, let's just show you that right now, Kale, if you want to swap over to this guy, because it's worth just worth describing here. So I've got my line here. I'm pulling between these 2 points. There's one on either end here. What I say by vector, I'm adding a bunch of tension here, and then I come over and I pull in the middle. So remember our little deflection diagram? That little deflection diagram that we looked at showed that I can actually apply a whole lot of force to either end of this rope by pulling in the middle. Problem is I'm changing the vector. I'm changing the direction of the pull. So the farther I go this way, the less force I have and the less in line between my 2 points the vector is. So it's not always ideal. It's got a very short pull length, but that's what I call the bow and arrow, or the vectored pull. It is a very useful, practical way to do short, hard pulls. It can be cheap, it can be expensive, depending on how you like to pay your people. It's super easy to set up. You obviously just have everyone go grab the rope. You're limited in your distance by how tired people get, and you're limited in your strength by how strong your people are. But it can be useful, and that's where we add pulleys in and stuff to make things better. Oh, my dog just got in. All right, progress capture methods for people pulling. So I've got a number of these here. Excuse me just 1 second. So when you're setting up a people pulling progress capture, when you're setting up for people pulling, that is where you will often use a pulley, 1, 2, maybe more, but that's where you're going to build a system. And it's useful to have a method of progress capture, because it's a lot harder for everyone to stand there and hold at full force than it is to pulse and then lock off the tension that you generated. So these are a whole bunch of different progress capture methods. Obviously, you've got the porter wrap. We can use a friction hitch, rope clamps, belay devices, tree wrap. They each have their pros and cons. I'm going to demonstrate a couple little techniques here. We've got some video clips coming up, but I just want to run through a couple little pros and cons. Obviously, I already mentioned the rope clamps, belay devices. So like the Megawatt or the CMC clutch, those are belay devices, but guys in rescue often use those as anchors, and you can use them as progress capture. But what they will tend to slip at about 5 kN. At least that's what the Megawatt's rated for. Most of them are pretty similar. That's what the standard is, because part of the safety factor of these devices is that if you take a hard fall on a static line, it should slip a little bit rather than transferring all that energy into your body. So you're not going to be able to hold a whole lot of power, hold a whole lot of tension. But as the last part on a line, on a pulley system, you don't need as much tension. And 5 kN is still close to 1,000 pounds. So that's going to be plenty for 1 or 2 people. So if you can pull the rope and add tension, then it'll hold it. So that can be a good way to go. Of course, it's a little expensive. Now the tree wrap technique I will demonstrate as well, but it's a good way to very quickly lock off a rope with a little bit of tension with 150, 200 pounds. So Cale, if you want to go ahead and play the porter wrap sweating video there. This is going to be a quick little technique demonstration of how to get some tension and capture it on the porter wrap. So this technique is called sweating, and it's pretty straightforward, but it's a good way to get some more tension on a line. You go and put your half wrap on the porter wrap. Sometimes I'll use a full one. And the idea is, if I hold a little bit of friction here with my left hand, I can use the bow and arrow technique to add tension to my line, and then I can pull the slack out with my other hand. I'll just show you that again. I'm pulling bow and arrow, adding tension, and then I'm transferring the slack down with my other hand, maintaining tension, and then I can lock that off using the cleats on the porter wrap. So now I've got a decent amount of tension. So this technique is called sweating, and it's pretty straightforward, but it's a good way to get cool. So that technique there is called sweating. If you've got some good skills in sweating the line, I've found that you can get roughly the same amount of tension as you can when you're just pulling as hard as you can. So maybe 100, 120, 140 pounds if you're really good at it. That's the next little method here that is sort of an alternative to sweating. And this is, again, for pulling in line. You can sweat something horizontally or vertically. That's a great first screen there. But Kale's going to go ahead and show this other technique. This is one I prefer if I'm going to be just locking off a line, particularly guy lines or whatever, but it works quite well. So there's a couple of ways if you need to fasten a line under a little bit of tension. There's a couple of ways to do that on a tree here, and so I'm going to demonstrate those real quick. Obviously, here I've got a porter wrap already set up, so I'm going to put a half wrap in. And the first thing I'm going to show you guys is just kind of the lateral version of the sweating, the technique that I showed you before. Oops, got 2 wraps there. So sweating, again, just like we did when it was up high, you pull bow and arrow tension and then you transfer that tension to the other hand. In this case, I'm going to pull here and I'm going to take tension with my other hand. I'm going to pull here and then take tension with my other hand. So that's one way to then capture some tension by hand. I've got a relatively tension line here. It's not a lot of tension, but usually that's enough to lock something off. All right. I got the wrong video there, but Kale, see if you can find the other one. It's where I pull on the rope real hard, then kind of swing around the tree. If you find it, just shout out. I'm going to jump to the next slide there. So after hand pulling, the next thing that many of you have probably seen or tried are these come-alongs. Obviously, they're cheap. They don't pull very long, but they pull pretty hard. And you have decent control because you're actually there cranking it. So you got that manual feedback. You know how hard you're pulling in some sense. And so you do have some more control. It's hard to tell exactly because you have quite a bit of mechanical advantage, and they can pull really hard. The setup is pretty simple, though, which is nice, and they're cheap. They're really cheap. These are not something I would generally recommend. They're hard to release. They are kind of slow and cumbersome, and it is a little bit difficult. And because the pull is so limited, they're really only good for very short sections, and it takes a lot of time to reset them. So while it is a cheap solution and it can work, it's not one I would pull out of my box very often, but it's good to know in comparison to some of these other ones, and maybe that's all you'll have one day. Awesome. Kale's going to jump back in here and show that other clip here. One other way to secure a line under tension by hand, other than using the porter wrap, and I find I can actually get a little bit more tension with this method. So I'll brace my feet against the trunk, pull as hard as I can, capture all that tension with friction by going around the trunk. So I'll go ahead and give it 2 wraps here. I'm really only pulling a bite through, and then we'll lock this off with a clove hitch. And I find that I can actually capture quite a bit more tension with this method than I can even with using the porter wrap and sweating it properly. So if you master that technique, I find it's about 20% better than sweating the porter wrap well. And it's really quick, and you don't need to set up the porter wrap. So if you're just locking something off, or if you're going to use that bow and arrow vectoring technique I showed you before, that's a great way to do it. It's super fast, quick, simple, and you can capture that tension really well. The key to that is to maintain friction around the tree, maintain tension on the rope the whole way around. And if you go around the tree a second time, then it's really easy to lock off that clove hitch or the 2 half hitches in such a way that you don't lose that tension. So that's the tree wrap method. Love it. It's a good one. All right. So jumping on the Masdom rope puller, some of you guys have seen these. It's a takeaway of the come along. Obviously, you can pull a lot farther with it, but I already mentioned, I'm not going to take too much time. It's got a few major problems. I used these a lot early on. I had a lot of tree companies who would put 2 or 3 of them in the same tree to pull them over, and just keep adding more if you need more pull. But in that sense, they're simple. Obviously they work pretty reliably. The setup difficulty is minimal. They're fairly inexpensive, but they don't pull that hard, and the control is bad, and they're hard to back up. That's the problem I always had with them. Once you start pulling near limits, they start to slip, and because they start to slip. But because the way the rope goes around it then goes the other direction, you can't just back them up to the tree that you're anchored to. You have to back up in another direction. And that's it gets to be hard to do. And I don't like something that can slip when overloaded, but also can't be backed up easily. So combine that with the fact that it has to use triple strand, which then twists. It ends up being kind of a poor option for doing a simple 2-to-1 with it. you can sort of separate the vectors, have the rope anchored to one tree. I'm trying to move my hands. You have anchored to one tree through a pulley and then back to another tree where you're cranking, and that kind of keeps it from twisting up because you created some space. But you also reduce your efficiency of your mechanical advantage by opening up the angle. Obviously, when your ropes are parallel and directly in line with your pull point, that's when you're getting the maximum pull out of whatever your system is. So I don't use these much anymore. I'm not crazy about them, but they have their place, and many of you probably have. What I've replaced them with in my operations is the CMI rope jack. Again, this actually works well with a double braid. It's a little more versatile. You can use a lot of different ropes with it. It's not so picky. It doesn't slip. It'll break. You can't pull it too hard. You don't want to put 2 guys or 3 guys on that crank handle when you're adding tension. But with one guy, it's very reliable, very simple. It's pretty easy to lock off that tension using it with the porter wrap, like I'll show you in this video. It's very easy to control. You can put quite a bit of force on it. I particularly like to be able to double up when I'm pulling with this through a pulley. So I'm through a 2-to-1 and this device. If I do that, I can pull 1,000 pounds pretty easily by myself. So simple, robust device. The setup difficulty, it's a little bit tricky just because those things can flop around and be misconfigured. Brand new guys will have to be trained on it. And it's a little bit more expensive than the Mazda rope puller, a little more expensive than, say, a pulley or 2 cheap pulleys. But it's really not that expensive. I think it's $320 or thereabouts if you can get it on sale for a little bit less. And you get, it's a very versatile pulling tool. So the next little video clip here is going to show one of the ways you can use that to pull. I'm using it here in a vertical configuration, but obviously you can do the same thing horizontally. So similar to the 5-to-1, this probably gives me a comparable amount of tension. What I can do here, again, I'm going to throw a wrap, half wrap or a wrap on the actual porter wrap, and then I can crank this, and because it's mounted to the porter wrap, this device is actually maintaining the tension between the porter wrap. So this is pretty easy. I'll just keep taking the slack through until I'm happy with the tension here. And then, this is a little bit of a tricky maneuver, but it works really well. I add some tension, I'll release the lower catch, take my wraps, capture that tension. Gotta capture it really tight. And then as I release this one, I should be able to get that off. And now we can lower on this device. Awesome. So that's one of the ways I used to use that. It was kind of the replacement, or what I used in lieu of a GRCS before I got one. Now that I have a GRCS, I don't use that nearly so much anymore because, I guess we'll get there. I'll talk about the GRCS. But another alternative device is a compact 5-to-1. You can use it in a very similar manner as that rope jack. You can use it in a lot of different ways. It's very simple. There's not a whole lot to it. I've got one sitting here. Well, I'll show you one on the table in a minute. These are a few commercially available options here. We've got the Edelrid Ka, this one called the Aztec that's made by Rock Exotica. This other one by Harkin. I forget what it's called offhand. All excellent devices. They're Kale, can you show the PowerPoint? These are all excellent devices. 2 of them use ropes. tangled. So this is one I built here in just a minute ago. Again, it's actually pretty expensive. I use quite a bit of expensive gear, but yes. Oh, okay. After we switched, or okay. So the what I was just saying here is I've got a little compact 5-to-1 system. It's essentially the same kind of idea as both the Harken and the Aztec, except this doesn't have any built-in progress capture. But when I was using this, I would store it essentially set up like this. I would store it all compacted, all ready to go, all sort of set up. But because I don't have a whole bunch of rope all open and stretched out, it's a little bit slower to deploy perhaps, but it doesn't get all tangled up. And so I'll have the rope in a big bag. And when I go to use it, I'll just hook up the bottom, hook up the top, and then pull it, or I'll hook up one side and then pull the other side to wherever my pull point needs to be. And then I'll start using it. But it just stores a little better when it's all compacted together. There's a lot of hardware, a lot of ways you can build one of those things. You would have trouble building one for less than what you could buy the Ka for. It's actually a great option. So as far as our scale here, the control is good. You've got 5-to-1, so one guy could pull, roughly. One guy could pull really hard by themselves. Input force pretty high, 5-to-1. Again, that's a lot of mechanical advantage. The distance of pull is kind of your big limiter here. You either have to set up a progress capture where you could kind of pull tension and then advance it again, then pull tension and advance it again, and that can be kind of tedious. Same with if you're trying to pull a really long distance, it would be exhausting. And the setup can be tricky, especially if you build it yourself. If you buy one of these pre-made systems, it's not so bad. But if you build it yourself, I even just standing here a minute ago trying to figure it all out, it's just not intuitive and would require quite a bit of training to have someone else set it up, unless you buy one of these sort of pre-made systems. And they can be, they're pretty inexpensive though. It's a good way, a good, simple, robust way to get some serious pull and power. So this next little video here is again one where I demonstrate using the Ka to take tension. And you can see how I've added in a prusik in order to be able to advance the system. So I have more than one length of pull. I can pull it and advance it, pull it and advance it. Alternatively, another way you can do it, you get a lot more tension out of this system. You can use a compact mechanical advantage system. I'll show you with the CT rope puller here in just a second. But this is an Edelrid Ka. It's just a 5-to-1 system. And I've installed a prusik up here on my main line. And the cool thing about this is that I can now I can pull a whole bunch of tension in this, and then in a more relaxed way, I can capture that. Now I can advance this again, and I can do it again. I can pull more tension. This actually has progress capture as well. So I just lifted a whole bunch of tension, a whole bunch of pressure into this line, and now I can go ahead and lock it off real easy there, and then release the mechanical advantage. And now I've got, once again, a tension line. So that's this. In addition to the 5-to-1, the Ka, I had a little soft shackle on the porter wrap, and I had a prusik loop and a carabiner up on the rope. That's it. That's all the gear required. It's a good way to go. It's one of my preferred methods. Now the capstan winch is another great option. Again, I'm always raving about the GRCS. When I first bought it, the first day I used it, I literally blew it up because I didn't integrate this little pulley so that the rope would fair lead into the capture here. And I just like ripped the thing off the tree, and oh, it made me cry. It was so sad. But the guys at GRCS were awesome. They had me parts the next weekend, and it was all back together, and I've been using it ever since. Fantastic tool. The control is awesome. You have manual feedback. I actually even use a powered electric drill, high torque angle drill to spin it. You get 20-to-1 one direction, 40-to-1 the other. So you really have a good sense of how hard you're pulling. The output force is phenomenal. You can get 2,000 pounds. I tested it just like this. I got 2,000 pounds just with the hand crank. which was, by the way, the most I was able to get out of a 12-to-1 system that I set up with very little throw, a 12-to-1 compound pulley system. Now, the distance of pull on this, again, is also excellent. The only reason it's not 5 stars is you can do better if you're pulling with a truck. You can really get a longer pull if you're using a machine. But otherwise, it keeps going. Because the rope feeds through it, you can pull as long as your rope is, or until whatever it is you're pulling hits the GRCS. Setup difficulty, it's not that hard, but it is, it's not that complicated, but it is a little bit heavy, and you figure it out, but it takes a little bit of setup. It's not, you could train someone pretty easily though. And the cost, it's 2 stars because it's pricey. These things are a little over $3,000, and they still needed to add this extra little pulley, and in order to be able to have the rope leading in correctly if I'm pulling horizontally. If you're pulling vertically, you don't necessarily have to have that pulley so long as the rope is coming in from the top. But a great system. The capstan winch is excellent. I've used it for all kinds of circumstances, and it's one that I always tell people, yes, it hurts, it's expensive, but buy it and you'll never regret it. You'll use it over and over again. All right. Lastly, we've got pulley systems. So here's where I want to jump in. We'll do some demos here. I'll probably try and spend, I don't know, maybe 15 minutes or so building different pulley systems for you guys, so you can kind of understand the difference between simple and compound, and see a few of my favorites. These can be great. You have really good control because, again, you're pulling by hand. The output force, you can get it as high as you want, so long as you got the mechanical advantage. The distance of pull, maybe it shouldn't be 4 stars. These are hard to get a lot of distance with because, again, you're either introducing a whole lot of rope, and so your 400-foot rope through a 5-to-1 pulley only gives you 100 feet of pull, and that's a lot of rope to lay out. But it's and you're limited. But you can also, attach a prusik in advance. There's ways you can kind of work with that. Setup difficulty, these are probably the most difficult to set up, or the most technical to set up. They're not hard, but you really have to understand it, and they can get expensive. Using good pulleys, using good ropes, using progress capture, it's a little bit gear intensive. They are more expensive than some of these other options, but they're extremely versatile. That's what I like them. Very often I will use a 2-to-1, and then I will use something like the rope jack. If I want to pull really hard, I'll set a pulley up in a tree, up nice and high, using a long, beefy 3/4 inch bull line, and then I'll run my first rigging line or pull line through that pulley and back, and then I'll pull on that with a rope jack or with a GRCS, and I know that I'm going to be able to pull just about anything over because I've got that massive 2-to-1. And if I need to pull more, I'll double it up one more time and have all the throw I want. So there's a lot of ways you can make them work. That's going to jump over here. And Kale, I would love to have your help sort of moderating the comments here, because I'm going to start going through these sort of at the beginning. But if folks have questions, then I would love to answer those. Let's see. Yep. The question was tying that bow in.
Yeah, the midline bow one that undoes more easily than the Alpine.
So here's that bow end. So some of you guys have learned how to tie an Alpine butterfly this way, where you pull the middle one up, you go around. Oh, I just did that wrong because that's not how I tie it. So this, your typical Alpine butterfly, gives you something that's really nice, easy to see, but you can pull any which direction, so that's nice, but it jams down. The circus bowline is what we call it. There was a different name for that one that you saw. You start with 3 loops around your hand, pull up the middle one, you go crossover 1, crossover 2, crossover 3, and then you pull that last one up and out and set and dress it. And it looks funky, but this can be loaded every direction. and it doesn't slip. Bind's really good. It's going to give you have the same issues that any bowline has, in that it'll reduce the strength of the rope by 60% or so. But it's much easier to undo because, like a bowline, you can take one of these little chunks after you've loaded it and pry it down, and then you can kind of turn it, and then you can push this one down, and then you can turn it and you can push that one down, and then it comes out super easy, even if it's loaded hard. That's the circus bowline. Love that one. Good knot.
Can you do that one more time for me?
Yeah, maybe I'll use a brighter rope too, because I'll use this one. See it a little better. So circus bowline 1, wrap your hand 1, 2, 3 times. You take the middle strand, pull a little bit of slack into it, fold it over, grab this middle strand now, fold it over the other way, grab this middle strand, fold it over the top, and now that last middle strand is the one that you pull and make your loop out of. And then you just got to work it all tight. The funny thing about this knot is it doesn't ever want to work tight. So even when it's dressed, it still feels like it's loose. It's funny.
You're saying it's the circus knot?
Circus bowline is what they call it.
Circus bowline.
Yep.
Okay. Gotcha. All right.
1, 2, 3. 1, 2, 3. Yeah, there we go. I did one extra there, but on the last one. Cool. All right, so for all of these demonstrations, we're going to assume our load is over here, the base of our light, and we're pulling this direction. Try and pull that way. So the first way, obviously, the easiest thing to do is 1-to-1. I've got my hands, I pull. I'm going to adjust that camera just a smidge. There we go. All right. Here's our 1-to-1. This, you got about 140 pounds, right? That's all you got. Now, if I want to double this up, then what I can do is I can either add a pulley midline, go double line, or let's see, I'm going to pull some slack here because the tip of this rope is already through a pulley. And so now I'm going to actually lock this side off. Just use a clove hitch here because that's what we've got. Rather a girth hitch. Just girth hitch that like that. So now when I pull here, I'm applying I'm pulling here, and my pulley is experiencing twice the load of my hands. One, because the load that I'm pulling gets transferred to this side. And so both these legs are pulling with roughly the same force, assuming we've got a 100% efficient pulley, which is never the case, but it's usually close. And I've effectively doubled how hard I'm pulling. And you know that because I'm pulling here, this anchor point right here, this anchor point is also pulling in order to balance my pull out. And so we've got two forces pulling. Now that would be a 2-to-1 system. Now, generally you might think, oh, okay, well, let's go 3-to-1 next. But I almost never use a 3-to-1 because I can get a 4-to-1 with the same number of pulleys as a 3-to-1. So to get a 4-to-1, what I'm going to do here is I'm actually going to install a pulley. So I've got because of how I set this up here, it may be confusing, but just stop me if you're not getting it. So I'm going to tie my little bowline, and now instead of running through a pulley here, this is going to be my anchor point. So I'm going to go ahead and put a pulley here. think to simplify this, I'm just going to use 2 ropes. Now you can do this with 1 rope, and generally when I do it, I use 1 rope. But for the sake of making it more obvious to see exactly what's going on, we're going to use 2. So with 1 pulley, I've got 2 to 1. And now I'm going to double that by adding a second pulley. Now this is one where it would make sense to use a rope clamp or to use a friction hitch. You know, I could tie a friction hitch right here and add my pulley midline. I'm just going to go ahead and use this little rope clamp because again, I'm the only one on the ground. I'm pulling by hand. So I don't care that I've got a rope clamp on there. I'm not gonna max it out. I guess I should put an actual carabiner on this thing. All right. Now, if I go, so right now I've got 2 to 1. If I take this tail, if I take my second rope here, I'll take my second rope and I go through this pulley and I lock off the other end of the second rope, little clove hitch. This is now no longer in play. That's essentially slack, right? But I've got 2 legs of line here that are anchored at the base. And when I pull on this leg, I'm applying one, call it a unit of force. This load is seeing 1 unit of force. So that means that this pulling point is seeing 2 units of force, which means that this line is also seeing 2 units of force. So 2 plus 2 is 4. So this is the most basic compound pulley situation. As I pull here, I get 4 units of force going into my end point up here. Now, it's important to note that in compound pulley type situations, you want to think about where the most force is happening, because I'm only pulling 1 to 1 here, but this is experiencing double my load, double my force that I'm applying, and that end point is experiencing 4 times. So the rope that I'm using as my anchor point, for example, if this orange rope was up a tree, if I pulled it through with a throw line, this needs to be the strongest rope of the whole bunch. I'll use my 3/4 bull rope up on top, and then I'll use maybe a 1/2 inch, whatever, and then I don't even care. I'll use my scrap line for this last bit because it's just not seeing much force. Same thing with pulleys. I'll use my big beefy pulley up here because that's seeing the most force, and then I'll use my weaker ones towards the end. And that's one of the ways you can kind of get by using smaller, lighter, cheaper gear and still generate a lot of force. So on a 4 to 1 system like this, I was able to get 620 pounds steady, and I was able to peak at 840 pounds using this 4 to 1 system. I pulled on a load cell, and that's what I'm 170 pounds. I'm strong, but not that strong. You can still get almost 800 pounds of pull, which is more than what you can get with the rope jack, just using what is 2 pulleys, 2 ropes. Now, when I'm down ropes, a lot of times I'll build this system more simply with just 1 rope, and I'll show you guys how I do that. So if I've only got the 1 rope, I've still got a whole bunch of slack to play with. So instead of locking off that other side, I'll lock off right here. Little clove hitch. And now I'll bring the tail of that same rope back up there. Now this looks funny. It looks like a funky system, because this is slack. This strand's not doing anything. But when I pull here, I've got 4 to 1 again. Now, if instead of locking that off here, I install another pulley, and I put a pulley here at our anchor. What is that going to give me? If you can do the calculation with me, I've got 1 unit of force here, 2 units of force. This one is seeing the same force as this, so this is a 3rd unit of force going into this. So I've got 3 units and 3 units. This situation is now a 6-to-1. So I went from a 4-to-1 with 2 pulleys to a 6-to-1 with 3 pulleys. I can generate an extraordinary amount of force. The other cool thing about this is that I've got 6-to-1, but I can still pull the same distance. So I didn't lose any of my potential throw in my system by adding this pulley. All I did was gain a little bit more mechanical advantage. And because both of these lower pulleys closest to me, both of them are only seeing at most double my force, I can again use fairly lightweight small pulleys. Now this might be a system where maybe if I have to pull real hard, I might not want to use this rope clamp anymore, because if I'm tripling my force, 3 times 160 is going to be, well, pretty close to. I mean, that's still going to be less than the 4 kilonewtons that this is good for. But I'm not going to risk it. I don't want to damage the sheath of my rope. So this might be one where I instead install a hitch cord. So that's where I might tie a VT, valve truss, or something similar. And there's a whole bunch of great friction knots. You should all know a couple, especially if you're a climber, because if you climb, you never know when a particular rope just might not interact well with the knot that you're familiar with. So occasionally they don't. It's very useful to know more. The other advantage of having a hitch cord like this, obviously you can do the same thing with the rope grab. So if I run out of room here, I can slide this back up. I can slide it up the rope, and now I can get more throw. But more than that, if I lock this off, and something's tight, or maybe a branch falls on this and this is all jammed up and I'm not able to release it at the trunk for whatever reason, I can release this here. So that really comes into play. For example, when I was testing these all out, it was kind of a knucklehead, and I put a hitch cord onto one of these lengths, and I had it go in both directions so that so I used a rope clamp so that I locked the whole thing up. There was no way to release it, and it got complicated for a minute there. But I swapped the progress capture device I had out for hitch cord, and I was able just to let it slide. So the beautiful thing about hitch cords is that they'll slip under really high load, which can be helpful and it's safe, but they're also releasable. So if you get in a pickle, sometimes you can release them yourself. So one of the things I mentioned before is if I know I'm going to be pushing limits and I put a hitch cord in there, one of the things I'll do is just tie a little bit of a backup knot here below the hitch cord. So if I tie a backup knot right here, a little alpine butterfly, this backup's going to decrease my pull a little bit, or it's going to decrease the strength of my rope, but it's in this leg that's only seeing 1 times my force, so I'm not worried about it. And then if my hitch cord manages to slide because I'm pulling too hard, then it'll stop into this and lock off, and I get some information. I know that maybe that combo isn't good. Maybe I need to try a different knot. Maybe I need to cinch it down harder. I get good information. And information keeps you from making stupid mistakes if you know what to do with it. All right. I'm going to simplify this a little bit. Does anyone want to see the 12-to-1? It would be a little bit tricky here. If someone wants to see it, I'll set it up real quick here. This is a 6-to-1. All you got to do is introduce another pulley up top. So we've got a tripling, a doubling, and then a doubling. That you can get 12-to-1, but it's not real practical. It was just kind of fun to set up before. I want to show you guys the progress capture using one of these, the megawatt. You can do the same thing with a clutch or a Petzl rig or an ID if you've got it.
I'm going to jump in here real quick. What is that?
This is the megawatt by Edelrid. This is just a personal descender. and it's basically designed to be able to climb on. But they also use these things as the bases for rescue systems. Again, if I've got this on the load line where my physical strength is the only thing pulling the rope through it, I'm not going to overload this device because it's good. It's designed for a one man's pull as hard as it can go. It's not a problem. That's another advantage of setting up a mechanical or a mechanical advantage system like this, where you've got all these pulleys. The final strand, the one you actually pull on, never sees that high of a load. Now, some of the parts in the system do get incredibly high loads potentially, especially the closer you get to your actual anchor point. But the end, you don't. So this little personal system, you can use as like a little bit of a progress capture device. Now, be aware, ANSI says don't mix climbing and rigging gear. So it's used with discretion, and this is debatably rigging depending on how you're using it. But obviously you won't want to shock load it. But the beauty of these sorts of devices is even if you do shock load it hard, this becomes another friction slipping point. So just like the hitch cord will slip under too much load, this device will slip under too much load. So long as you don't back it up, you're not going to damage the device by that rope slipping out of it. It serves as a safety buffer. But basically, I've got that here at my anchor, and now I can pull and it'll lock off as I release. If I want to release it, then I can operate this handle and it'll introduce slack back into my line. Does that make sense? I'm going to undo some of this here. Progress capture is a wonderful thing. I'll show another little cheaper option. If we've got, show you guys how to do a hitch cord. I've got another hitch cord sitting here. We've got a hitch cord. You take your hitch cord. This one requires actually kind of two, but I'll just do this one first. I'm going to tie another little VT. This is going to act as my progress capture. Now, anyone who's ever climbed on a system like this knows that that won't tend itself very well. You can't see it super well, but as I pull here, I can slide that knot up and it's going to maintain tension. And as it releases, it's going to have a little bit of sit back, so I'm going to lose a little bit of that tension. But one of the cool things you can do is integrate another pulley, another small pulley, as a friction advancing setup. So you can, just like you would for a climb system, I can take one of these guys, slip it underneath here, and now I've got a hitch tender. And generally what I would do is I would tie it off over here to this. I don't know if this is going to work here, but I would use another hitch cord going up here to hold onto this. Or you can use a rope clamp and a carabiner or whatever. Again, more gear, more complicated, but it does make it easier. And now it's simpler too. So as I pull here, that pulley tends the hitch cord for me. And I don't have to worry about advancing it. I can put 2 or 3 people on it, which is another kind of nice thing. And no one actually has to stand here and tend the hitch. So I can get more mechanical advantage that way. Now, I don't have to do that in this complicated 6-to-1 situation. I can do it even with just a 2-to-1. And if I've got 2 guys, now I've got 2 guys on a 2-to-1 and I'm getting 4-to-1 basically, but with the extra manpower. And that'll serve to lock it off. Once you're done, once you've taken the tension, if you're worried about your hitches slipping, you can then just lock off that branch or lock off the remaining rope, just like I showed you guys in that other little video. And now you got something that's going to be rock solid for you. All right, I'm gonna probably, I've got a few more we could do, but I think I'm gonna mostly call it here because I want to get to one last slide and if they give a little chance for some questions before the end. So mechanical advantage, I would be remiss to not mention using equipment to pull. Now, equipment can be very hazardous to use to pull. It depends on your situation, depends on what you're doing. It can also be very safe. Now, obviously, big, heavy things can exert a lot more force than us small, weak, frail humans. And it's very difficult to measure how much force that is unless you've got a dynamometer and you're setting all sorts of crazy things up. But you can compromise in such a way that you can actually have more control if you know what you're doing. So obviously, big equipment's the most expensive thing. It's pretty easy to set up. Usually you just tie it on and pull, right? Distance of pull, that's the best thing about heavy equipment, is it'll just keep pulling and pulling and pulling. It doesn't care. It doesn't get tired, and it doesn't stop pulling hard unless you lose traction or something. And your output force, it's hard to pull any harder than you can with a truck or with a skid steer, even a mini skid steer. The two big issues are cost and control. So if you already have the equipment, great, it's not extra cost. But control is a big one because, again, over pulling is a huge risk. That can cause all kinds of hazards, and it's really hard to know how hard you're pulling when you're in something big and strong. So one of the ways that you can mitigate that is how I was showing you here with the friction hitch. So maybe you put the truck on a friction hitch around one of your ropes, and if you pull too hard, the hitch slips. And so that's one way to mediate it. Another way that I've seen surprisingly few people do is actually integrating a porta wrap onto whatever it is you're pulling. So for example here, I don't know if my face screen is covering everyone else's bottom right-hand corner, but that device that's hidden behind my face, at least on my screen, is called a branch manager. Oh, there we go. Thanks, Gail. And if you look at the, over here at the top left-hand corner of the branch manager, what does that look like to y'all? It's a porta wrap. So I don't like where it's positioned on this device because pulling from up high like this will cause the device to tip forward. And so you limit some of how hard you can pull by putting it all the way up here. But this is a wonderfully useful piece of equipment because I can throw 3 wraps on there and have someone hold onto the rope. And now I have manual feedback and manual control of how hard my machine is pulling because they can let it slip. They can act like a clutch that's limiting just how hard we're pulling on the rope. And that is a fantastic solution. So I actually welded a cylinder with those little T-bar on it onto the side of my grapple. I just had a root grapple on my machine, and it was fantastic. We used that thing almost as much as we used, more than we used the GRCS. And when you have them both, it's incredible because now with all that pull distance, sometimes I'll just put a redirect at the base of the tree. I'll have my rope coming off the machine through the redirect, up into the tree, through a pulley, and then down to a branch, and we can start lifting branches. So if I've got my machine pulling here, and then I've got these 2 pulleys, I can throw my, do a little tip tie, have my groundsman on the mini skid where he's facing me and backing up, and someone else is holding the rigging line wrapped around the porta wrap that's welded to my grapple. And he can let it slip if things get too crazy. He can let the rope run if it needs to, if it breaks free. There's a lot of potential control that you can do. So if I'm doing a tip tie rigging situation like that, sometimes I'll throw the GRCS on. Sometimes we'll just throw a pulley on the bottom and use the ditch witch or use the machine. It's a really great way to minimize that particular liability. You can do the same thing with your truck. You can tie the porta wrap onto one of your tow hooks in the front and just pull off the front of the truck using a tow hook or using the porta wrap. So that's generally how I recommend if you're going to pull with something heavy, if you need the force, you use that and know the limits of your rope, know the limits of your truck. Obviously the traction and just how hard you can pull the traction is going to vary wildly, and that's going to determine just how hard you can pull. So a lot of times if I really need a lot of pull and I'm using the truck because I need all that power, oftentimes I will back up whatever I'm doing with a second line so that even if the truck slips, I will have another line that's locked off with a bunch of friction, or I'll have a wrap or two around a tree that I can cinch and I can add friction if things start to sit back. There's ways to make that more under control. The other thing to consider when using machinery, I'm thinking particularly like using an excavator. Excavators have incredible traction. They're really heavy. And so occasionally you'll walk up to a back of a trunk or whatever, give it a little bit of a bump. I've seen this a lot on big land clearing or roadside clearing. Sometimes the excavator is just the best, most efficient way to deal with it. But you walk up to the back of the trunk, give it a little push, or run it out on the rope and give it a little pull. But the thing about these machines is they're very slow. Excavators in particular are really slow, but other machines are slow too. And sometimes you need to pull for a decent distance. So it's oftentimes a good idea to trade off a little bit of leverage for the torque that these machines can offer. So sometimes if I'm pulling with a truck, for example, I will choke my rope around the trunk maybe at the halfway point rather than trying to get it really high and risk breaking out tops or risk having the rope pull through branches. I'll just choke it off 20, 30 feet up the tree, knowing that I've got enough leverage because I'm pulling with some heavy equipment rather than, then I'm trading off some of my distance for the torque. So if we go back to our very first little diagram here, when I've got a whole lot of power, I don't need so much distance of pull, and I can still get work done. The other way you can kind of do the same thing, or if you're using a machinery to drag brush up a hill where you again don't need that much force, but you've got a long way to travel, you can use a reverse 2-to-1, a 1-to-2. You can put the pulley midline and then have the rope anchored past your load, and you can use the pulley, drag the pulley with the truck, and then you're getting twice the distance of material movement at half the distance of machinery movement. So that's another kind of cool thing you can do when you've got all that extra power to work with when you're dealing with heavy machinery. Obviously, you got to be really careful about spring loading your ropes. If things break, making sure everyone's in a safe place. No one should be in line with the rope. If you have a redirect, and I want to demonstrate this at the table real quick here. If you have a redirect in play when you're pulling really hard, then it's all the more important not to stand anywhere where that redirect, where if the redirect broke, it could fling things. So just pull all this off of here real quick. We're just going to go super simple. So I've just got, this is my pull rope. I'm pulling really hard in a straight line, but my anchor, so maybe this is where the road is. It runs over here, but I need to pull the tree this way, more towards me. And so I redirect over off to a different anchor point. So now I'm redirecting way over here, and I'm pulling this way, keep my truck on the road, right? Well, there are a lot of danger zones in this configuration. If something snaps up here, the rope could come flying this way. If something snaps over here, the rope would come flying this way. If something breaks right here at the pulley, the rope could go flying that way. So it's really important to know where those zones of danger are so that you can get your crew, get bystanders, make sure that you've gotten rid of anything valuable in any of those directions based on what you've decided is your weakest link. So as you introduce more variables, more redirects like that, you have to just spend more time thinking through, all right, what's the worst case scenario? What could go wrong? And how do we avoid that being catastrophic? All right, I'm going to call it there for now. I want to give us a few minutes to ask for questions. We got 10 minutes. Cale, do you got any good ones there?
So I have this problem where I think you've done such a great job that I don't really have any questions here. I know people have been paying attention because they've been yelling at me whenever the audio goes out or something like that. But yeah, no questions so far. There's a little bit of delay. I'm sure when they hear that you're asking for questions that some will start. I just want to reiterate that this idea of being keeping people away from the inline danger of the line that you're pulling on is important, because that's something that personally I haven't heard anyone talk about, and I've done a whole bunch of these webinars.
Yeah, I mean that's
I really
a huge
like that.
thing. It's so easy to get caught. Like I'm always yelling at groundies, and of course, if whoever it is who's pulling on it, and this is one of the risks of the manual pulling methods, you almost inevitably have to stand in line.
Mm-hmm.
If you can tuck yourself behind a tree and pull, great. If you can't, you are a little bit in line. And that's why, again, to mitigate this, it's useful to know where the weak links are and to set the weak links in such a way that if they break, it pulls things away from you. So if I'm, for example, using a rope jack anchored to a tree with a rope that goes out and back, I want to make sure that the pulley out there and the sling around that tree and whatever it's anchored to is plenty strong, so that if something breaks, it's going to be on my end. So it could go away from me. But yeah, anytime you've got things in either direction, it can happen. I mean, it's so fast. And if you're pulling with trucks, you almost inevitably end up having a redirect or two, because the truck has to stay on the road or it has to stay on good traction. And so you have to get the rope down to where the vehicle is. And so that just amplifies the number of potential failure points.
Oh, I've seen all the compilation videos of people using chains to pull stumps out of the ground with their trucks, and the stump goes through the back of the truck and breaks their windows and stuff.
Yeah. Yep.
The other thing is that I do think it's important that people know how dangerous that is, pulling in line with that. They actually do a tug of war ceremony, or like a thing in India every year with like hundreds of people, where if the rope snaps, it pulls people's arms off. Like it's an amazing amount of force.
You just don't think like, oh, we've got 20 people on this, but yeah, 20 people pull, like if they're big guys, they're pulling nearly 200 pounds. It's 40,000 pounds. You could break a big rope with that.
That's dangerous.
Yeah.
Okay, so JJ is asking, where do you tie everything off? Like off the porta wrap, or do you use a rigging plate?
Rigging plates are awesome. I don't generally own them. A lot of times what I will do is, that's a great question, by the way. A lot of times what I'll do is I will have one thing on the loop of the porta wrap, and I will have another end anchored around the tree. And that gives me a little bit of space, because the twisting thing is a problem. Anytime you've got too many ropes too close together, they start to twist up, and then you lose some of your advantage. So I'll have 1 or 2 ropes on the tree typically, and then that's it. If I have more than 3 contact points, then I'm almost always going to use something else. I'm going to use a rope jack, or I'm going to use a car or whatever. But yeah, so I don't usually anchor them all to the same point. If you had a rigging plate, that would be cool, but it's not really necessary. I'm tying raw ends of rope, or I'll use the bite. I'll make 2 wraps around the tree with a bite, and then a couple of half hitches. If you anchor a rope around a tree, like I showed you guys in that video, you get a lot higher percentage of the rope strength, and you make it really unlikely that the rope is going to break there, because the friction around the tree is distributed really evenly around the rope, so that the point where the knot deflects the rope is actually, it doesn't experience much force. And so you can get 90-95% of your rope's MBS with that sort of extra wrapping. Whereas if you tie a knot around a carabiner, that almost always becomes the weak link. That's where you lose 40 to 70%, depending on what knot and what ropes and what carabiner and all that. So.
All right, great. The other thing I have here is on our YouTube, Homer Jr. asking if you can demonstrate the 1 to 2 mechanical advantage with pulling with a truck.
Okay. Yeah, I'll show you guys over here real quick.
Set that up. Yeah, we can do that.
So the 1 to 2 is only relevant when you're trying to pull something a distance. So I'll show it kind of in that scenario. I've got my rope here. Let's just say we've got some, we'll use my green bag that I had as an anchor over here. This is now our, this is our pile of brush that we're trying to drag along the road a long way.
Sounds good.
And this rope, this orange woodpecker rope is the one we're going to use. So the first thing you do is you anchor one end of the rope off. Anchor one end of the rope off to something past your, or around the same area that you're actually pulling stuff out of. So got your one thing anchored down below. And then got my pulley here. That's where the truck's gonna get attached. Probably I would have another tether going to the truck, but I'll just hold it with my finger. And then I'm gonna tie this end right here. Let's see, we'll go. This one's better with a lot of rope. You need kind of long distances because I can only ever pull, well, until that reaches me. So if I pull this right now, I'm pulling, my hand moves half the distance that the bag moves. Reset that there. Does that make sense?
Man, pretty great.
Cool.
Yeah. That is all of the questions I have so far.
Great.
I want to thank you again. I have one question for you. Is there anything that you think your coworkers at Edelrid would like you to talk about right now?
Yeah, I mean, I'd love to. There's all kinds of things. Probably the big one right now is just the I want to talk about the Tree Rex saddle briefly. My YouTube video I did when I only had it a week or two didn't do it justice, and they're going to be going on sale in a couple places here this summer. So just keep your eye out for that because it is a really cool, very fully featured saddle that at kind of a ridiculously low price point for as fully featured as it is. It's one I've been using for a couple years now. It's got a couple quirks. It's not perfect, but it's great. It is really good.
You're climbing on the Tree Rex?
Yep, the Tree Rex. I'll show you guys.
Nice. All right.
And it's got some kind of cool features that you won't see anywhere else. One of them, this is mine that I've got all beat up, and I've got some weird mods to it. But one of the cool things it's got is this little, it's called the SRT loop. And it's just another rated attachment point, but it's super close to your body. So when you want your system nice and close and tight, like when you're working on a spar, it gives you a great point of attachment. And then we have a chest harness that integrates with that makes this fall arrest, like a CE fall arrest rated system. So you can climb right out of your bucket truck wearing this right into the tree, which is nice too for all you bucket bunnies. And then a totally underrated but really awesome feature are these gear loops. They're just perfect. Like you couldn't have better gear loops, which is kind of a dumb thing to say, but it's so nice that they don't really snag. They're just slim enough, but they stick out and they're rigid. So they hold up really well. And you can always like rack your gear. You always know where it is. And then of course, it's got the little plates on the sides that gives you kind of a secure spot for your bigger carry tool, rock exotic transport or whatever. And the awesome ventilation too. They breathe like nothing else.
Awesome. Great.
Yep.
Well, thank you very much, Josiah, for doing this. Thank you, Edelrid, for lending us Josiah. I have a feeling we'll be doing some more projects together in the future. In fact, I think I'm allowed to say that we are starting a new initiative on sustainability in concert and coordination with Edelrid and their Climb Green project, um, to kind of bring some more sustainable options in the tree care industry on products to our store, to tree stuff, and to, I guess, the entire industry as a whole. Edelrid's really leading the way on that with their Climb Green. I don't know if you want to talk about that a little bit.
Yeah, just 2 seconds. Yeah, I'll give you. I'm stoked to be working with you guys. I think what you're doing is awesome. It's going to make a difference on the industry at large. Doing something that's hard to do. The transition to more sustainable manufacturing, more sustainable practices is always challenging and expensive. To be the front runner, it's an investment to be sure. So if you guys don't know, Tree Stuff's going to be they're going to be kind of highlighting some products, not just from us, but from folks all over that are stand out and exceptional in the whole manufacturing process, or in some other way that they're just built to last forever with all these great replaceable parts, or they've used less water, used less power, or they're made of recycled materials, whatever it happens to be. Those things are not easy to do, and it's often more expensive than just doing it the way it's always been done. So I'm stoked to see you guys kind of highlighting some of that. And yes, for the moment, Edelrid will feature prominently because we've been doing that a long time. It's something that the Germans care a lot about and have invested in for a decade now. But it'll be good to see the whole industry have that opportunity to show off a little too. I think it'll bring everyone forward.
Yeah. I was supposed to post about that on Earth Day, but I didn't have a logo artwork drawn up yet, so that was my bad. But we'll have that soon. Thank you very much, Josiah, for your time. And everyone, make sure that you find that link to the quiz in the comments. I will post it in a moment here in the description. If you get 16 out of 20 on that quiz, then you can get 2 CEUs for free. That's if you're watching it right now. If this is in the future, like 6 or 7 days from now, it's only going to be worth 1, but you will always be able to come back, watch this again, take the quiz, earn a CEU just from watching it and passing that. So thank you very much.
Any other topics you're really interested, want to hear about, post them in the comments, and we'll try and get to them. If we can't get to them during a webinar, maybe Strider will make a video about it.
Yeah, definitely. All right. Thank you very much. And have a nice night, everybody.
I'll take